Hello, you're here for one more lesson of this 4M CAD training course, and the topic for today will be how to work with coordinates. So, to start talking about this topic, you need to know that for the accuracy in a drawing, you can locate specific points by entering coordinates as you draw or modify entities. It's common to every CAD software. This is common sense. In 2D, you can enter 2D coordinates. In 3D, you can enter 3D coordinates. So it's easy to understand. Many commands inside the program require that you specify positions as you draw or modify the entities as I mentioned before. You can do it by selecting points in the drawing area with the mouse, or by typing the coordinates, the values of the coordinates in the command bar, so in this area here. And this program locates these points inside the drawing using what we can call a Cartesian coordinate system. Okay, so how these coordinate systems work? These Cartesian systems uses 3 perpendicular axes. You can see in this area the coordinate system because we are on a 2D plan, so you see only 2 of the axes because the z-axis is pointing to the user, is pointing to us. So every location in a drawing can be represented as a point relative to this coordinate system. So we have an origin and all the points are represented as a measurement from the origin to the specific point. And this origin, what you can call the 0, 0, 0, 0, 0, 0, because it's 0 in every axis, in the x and the y and the z axis, is referred as the origin. Okay, so we can see also that we have one coordinate system from the program that comes every time you start a drawing, and that is called WCS, or World Coordinate System, so the origin of the program. You can notice also that in the program you get this x-axis in red, the z in green, and the y in green and the z in blue. We can rotate this a little. So for example, let's do a dynamic view. We can do the orbit. So if we rotate it a little, you see the Z in blue. Okay. Besides this, you can notice also, now we are not on a 2D plane, but I will select it again. So top. We can see also that every time we move the cursor in this area here, the coordinates are changing. So you have the coordinates on the format x, y, and z separated by the commas, and the last one is the z. So you see, because I'm working on a plan, the z does not change. Okay. I can work around this if I choose the f6 function. So f6 coordinates are off, so now they are off, they do not work. If I do it again, on, so they are working again. Okay, so what can I tell you more? Every point we can work around these coordinates. So for example, if I click one point, you see this is has a coordinate and this one has a coordinate. Okay, I can ask the system to give me the point or a specific point, and I can go here to the tools menu, then drawing aids, tools, then inquiry, and then, for example, ID point, and we can select one specific point clicking or just doing something like this, for example. Okay, and we get here the coordinates of this point, so x, y, z because it's in the plan. I can call also this function by writing ID point, for example. I get the same thing, or just ID, I get also, clicking a point, I get the coordinates of that point. Several ways to use the same function. One thing that I missed, if I want to change this notation of the colors to one single colors in all the axes, I have somewhere around the options, I don't know where now, but I have the settings somewhere, it's not very important, but I have one function, preferences probably, regarding the axis, where I can choose to have all the axes in the same color. It's not very important, I will let you know later, no issue about it. More important, using the 2D coordinates. So we have several things. So 2D coordinates, the first one is, in terms of the 2D, we have the absolute Cartesian coordinates. And you can put a point every time you are in a function that you are asked by a point. You can click in the drawing area, as you know, but you can give the coordinates in the command bar typing. So I can say this kind of thing, 10, 20, and this is an absolute Cartesian coordinate. So this is 10 units in x axis and 20 on the y axis, okay, separated by a comma, and it is regarding the origin, the WCS. Okay, this is one way. We can have, instead of being an absolute Cartesian coordinates, we can work with relative Cartesian coordinates, which is basically the same, but instead of saying 10, let me write down here, it is more 10, 20. So writing down, and then I can come here and say like this, okay, this is the absolute one, but I can use another format, which is with this symbol, the at, and then using the same notation, and this wants to mean that instead of looking to the origin, to the 0, 0, it will look for the last point. Typically, you can use something like this, as a first point clicking somewhere, and now I can go and write down like this, and it will look to the point I've clicked previously, and it will measure 10 units in x, 20 and y. Let us say enter. It went wrong. Let us try again. Okay, 1 point, and now okay, and it has done what I asked. So 10 in x, 20 in y. Besides this absolute and relative Cartesian, we can work with polar coordinates also in two modes, absolute and relative. For example, I can make a line saying the distance regarding the point and the angle regarding the x-axis, and it's something like this. I will write down on the line just to explain. So the size of the vector, it's 20 units, then I use this symbology, and this is the angle considering the x-axis, so for example 45 degrees, okay? And if I use this notation, it's again regarding the origin. If I say before I put this kind of thing here, then it is relative to the last point. Okay, let us use a practical example. So for example, one point here, and I can say the at, and now 20 in the size of the vector, and the angle will be 45. Okay, something like that. It's very easy. Regarding 3D coordinates, we have the possibility to work again as a normal insertion of points. So for example, one point, okay, I can give the coordinates, and now because I was using only 2D format, X and Y, I can say, for example, something like this, a coordinate in X, Y and Z. Okay, this is one way. It's equal to the similar possibility. Besides, we have spherical coordinates, and the spherical coordinates are it is something like this, with this format, size of the vector, so the length that goes from one point to another one, and it can be in absolute or relative, again having this or not. And then I put this symbol, I put one angle, and this angle is the angle on the XY plane, so it is similar to the polar ones, so it's an angle from the x-axis. And I need to put another angle, for example this one, and this is the angle that comes from the x and y plane to z. Okay, and these are called spherical coordinates. Okay, I will not go too much further in this 3D area, because we will have later in this course lessons specific for the 3D, where we will see these functionalities in deeper detail. So again, this is the format for spherical coordinates. And we have one more type of coordinates used for 3D that are called cylindrical coordinates. And the cylindrical coordinates, it is something again like this. So for example, the length of the vector between the 2 points. Then you can put again the angle, this time from the x and y plane, okay, and separated by a comma you will put, sorry, let us start again. Now for example, it's assuming another thing, so let us 50, let us say angle 20. It's assuming another thing, so I must use it here as text to show you what I want to do. One second please. So the format, it is the size of the vector, then this sign, angle from the x and y plane separated by a comma, and then you put, for example, a value which is the z coordinate from the x and y plane to the z level where you want to place that point. Okay, these are the cylindrical coordinates. There are no better or worse methods, they are just different methods. Okay, we will have time to practice on the exercises we are publishing for this as a complement of this course. For now only in 2D, but later we will have also 3D examples, but also with the lessons focused on the 3D commands and 3D options of this program. So these are the cylindrical okay, these are the cylindrical coordinates. For last, to tell you that until now we just mentioned the WCS, or World Coordinate System, which is the system that comes by default with the program. But we have possibilities to create some user-defined coordinate systems. For example, we can do this in Tools, and then UCS. We have a lot of things here, a lot of possibilities to create systems. This is the possibility to activate the world coordinate system, but a very easy one, the origin, and you just give either by coordinates or clicking somewhere. So you see now this notation here, red, and green. So here it is the 0, 0, 0, and if you see this moving, when I'm close down here, it's almost 0. So this is a way to create your own coordinate system. If I need to go back to the world, so again, UCS, world, okay, and we are here again. Among these possibilities also, we have others like creating one coordinate system by an object, okay, and it will follow the orientation of an object. But we have also the possibility to save these and have a list of coordinate systems to call later. So as an example also, let's create one origin, okay, here, and now I will give it a name. So for example, UCS1, okay. I will call the world coordinate system, and I can go there again and do the restore and UCS1, and it is back. So I can manage these systems also with this way, okay. So I hope this was not too much confusing about all these coordinates. Anyway, for any help, you know that you can reach us through the normal ways, and I invite you to check the exercises we are publishing at the same time as these lessons. For now, again, in 2D, but we are almost reaching the 3D exercises, and in there we have a lot of different examples and methods, and we show also this management. Among other things, we also show the management of these coordinate systems, user and the global one, as we mentioned, as a WCS.